Hello everyone, welcome back to this sequence of lecture videos on trigonometry. And in this one we're going to do one of the classical applications of trigonometry, which is land surveying. A lot of times surveys, they choose some important points in the ground, measure distances, measure angles between them, write it all down, goes into the county records so that people can know which properties are all around in the area. And then from that, you can do different sorts of calculations. So they give you enough information to be able to figure out the shape of the property. And so in this case, what we're going to do is find the area of this particular surveyed property. The setup, at least in this textbook problem, is that there's a lot for sale and it's in a subdivision. A subdivision is some piece of land that has been broken up into smaller parts. And they're saying it has the shape of a quadrilateral as shown in this figure, and we have to find the lot size to the nearest square foot. So one thing to know is that if you have a quadrilateral where you only know the side lengths and one angle, it's ambiguous because these two sides, this one and this one, they could also have come in this way, which gives you a very different area than where it goes out like this. So we're going to assume that the figure is accurate and that this angle is supposed to be an obtuse angle. Okay, so how should we start? One thing that we know is the law of cosines. The law of cosines says that given two side lengths and an angle between them, we can figure out this side length. Let's call that C. And the thing about side lengths, so the thing about trigonometry is that basically, well, every polygon can be turned into triangles. So that's why it's all about triangles. I've broken this quadrilateral up into two triangles, so now it's just a matter of working out the details and using formulas. Okay, so law of cosines, what does it say? It says that c squared is 140 squared plus 86 squared minus 2 times 140 times 86 cosine of the angle between them. So in particular, c is the positive square root of this quantity. I'll just write this like this for now. I guess let's may as well punch it into a calculator. So square root of 140 squared plus 86 squared minus 2 times 140 times 86 times cosine of 85 degrees. And we have to make sure to use angle mode rather than radian mode for this problem. And that gives us about 157.789. So I'm going out to multiple digits of precision to make sure that we're going to be able to round to the nearest foot in the end. Okay, so now that we have this C, what we can do is, first of all, I guess we could apply. So remember, the area of a triangle of a side triangle is 1/2 product of the sides times sine of the angle. So we actually can figure out this area. Let's call that A1 and this A2, because the full area is A1 plus A2. So A1 is 1/2 times 140 times 86 times sine of 85 degrees. And let's punch that into a calculator. So 0.5 times 140 times 86 times sine of 85 degrees is about 5997.09. I'm just going to give us one more digit for safety over here. So instead of 8, 9, it would be 8, 8, 7, 8, 8, 8. That should go to 4 digits. 2 digits is probably enough, but I just want to be careful. Okay, so we've got half of the lot area. Now we need to figure out this A2 area. We could use Heron's formula, but I don't know. Let's just use the law of cosines again to figure out this angle. Yeah, let's do this angle. Let's call this theta. So, okay. Law of cosines. So, just checking to see that there's no faster way to do this. Okay. So law of cosines, we have c squared is 38 squared plus 138 squared minus 2 times 38 times 138 cosine theta. And we can then solve. So I'm just going to do a bunch of steps all at once. So I can add this to both sides, and it can also subtract this from both sides. So 38 squared plus 138 squared minus c squared. And then I can divide by this quantity. Okay, so then let's approximate that at this point. So 38 squared plus 138 squared minus 157.7888 squared over 2 times 38 times 138. It's approximately negative 20.6042. Then let's take the cosine inverse. So theta is approximately cosine inverse of negative 20.6042. And let's make sure we do that in degrees. So mode degree, cosine inverse of that. Okay, there's obviously something wrong because cosine it has to be between -1 and 1. So what went wrong here? You can't see this, but I accidentally added the 138 in the denominator. Oops. So I'm going to fix that. Yep, so -20. That was absurd. It's 420, let's say 4. And then let's fix this one. Minus 0.4204. And so we calculate the cosine inverse of that answer, and we get 114.86, let's say 1 degrees. Okay, so that's bigger than 90. That's good. It kind of matches the picture, though you can't always trust what the picture shows you, because they might not actually be to scale. Okay, so we want A2. So A2, the area of this other triangle, is 1/2 times 38 times 138 times sine of theta. And let's punch that into the calculator. 0.5 times 38 times 138 times the sine of 114 of that answer. And that is 2379.03. Okay, so then the area is A1 plus A2, that's the total lot area, which is approximately, so we have 5997.09 plus this new answer, which is 8376.1, 12. And we're supposed to go to the nearest square foot. So 8376 square feet. And there we go. Done a little bit of calculation that a surveyor might do. Like a professional surveyor probably has fancier tricks to be able to calculate this faster, but you know, me as a mathematician, I know my law of sines and our law of cosines, and I know how to find areas of triangles, so that is what I fell back on. Okay, hopefully that was interesting in some way, and I'll see you next time in a future lecture video. Bye.